Imagine a sprawling golf tournament. You've got a camera rigged to a cart, tracking a drive, maybe a mile away from the production track.
Right, a massive distance.
Exactly. So how does a massive 12G SDI signal survive that distance without dropping a single frame? The answer isn't some giant glowing satellite dish. It's a piece of gear the size of a candy bar.
Yeah, it's incredibly small.
Welcome to today's deep dive. We're looking at how massive video signals survive the absolute chaos of live event broadcasting using the AJA FiDo-4T receiver as our map.
Because, pushing 12G over standard copper SDI cable, it hits a physical wall incredibly fast.
Right.
You're essentially fighting electrical resistance. The signal just naturally degrades and, falls apart over distance.
Okay, let's unpack this, because sending data over copper is like trying to drag a heavy physical box across sandpaper, right? It takes energy and things get scuffed up.
That is a perfect analogy, yeah.
So fiber optics solves this by converting that heavy electrical video data into light. It's essentially just blinking light bouncing off the internal mirrors of a glass tube.
And this specific AJA receiver leverages single-mode fiber to push that light up to 10 kilometers.
10 kilometers?
Yeah, that's almost 6 miles. In the fiber world, multi-mode is it's like a wide hallway where the light bounces around and eventually smears over long distances.
Oh, I see.
But single mode is a tiny microscopic tunnel. The laser shoots straight down the middle, no bouncing, no dispersion.
Okay, so think of this receiver like a specialized high-speed bullet train that can travel 6 miles instantly without losing a single piece of, HDR luggage.
What's fascinating here is why that 10-kilometer range actually matters.
Right, why 6 miles?
Because it connects remote field cameras directly to central production hubs without any signal degradation. You get pristine HDR data from the edge of the course all the way back to the switcher.
Which sounds great in theory, but I have to ask a critical question here.
Sure.
If we're just converting a cable type, why are we looking at an industrial box that costs, $1,185?
Yeah, $1,185.
Right. And you can find consumer-grade fiber converters online for a fraction of that price. Don't they do the exact same thing?
Well, on paper, yes.
Yeah.
But not when you factor in the physical reality of a live production environment.
Because it's chaotic.
Exactly.
Yeah.
A broadcast truck is essentially an active construction zone. Those cheap consumer converters, they use standard plastic friction-fit optical ports.
Oh, I see where this is going.
Right. A production assistant bumps the rack, the fiber shifts a single millimeter, and your entire national live feed just goes to black.
Just from someone bumping into it.
Yeah. But the AGA unit uses a locking ST barrel connector. It's a mechanical, metal, twist and lock mechanism. It physically prevents those catastrophic disconnects in high-stakes mobile environments.
Okay, so it's about physical security just as much as signal integrity.
Absolutely.
And looking at the physical specs, it's incredibly compact, like 4.6 by 1.7 inches and less than an inch thick. And it runs on 5 to 20 volt DC, drawing a maximum of only 2 watts of power.
Which is key, because that isn't just about saving electricity on the truck. Low power draw means it barely generates any heat.
Right, and heat is the enemy of electronics.
Exactly. If a device doesn't generate heat, it doesn't need internal cooling fans. You can completely seal the circuitry against the dust, dirt, and moisture of a live field rig.
Oh, wow. So you can cram it tightly behind a sweltering equipment rack without worrying about it melting down.
Yeah, it operates safely up to 104 degrees Fahrenheit, which is why they can comfortably slap a 5-year warranty on it.
Makes total sense. It also handles something called reclocking, which seems crucial here.
Oh, it's vital. Because over 10 kilometers, even light signals can experience jitter.
Jitter meaning the exact timing of the data packets gets a little wobbly.
Right. This box doesn't just passively receive the light. It actively cleans up and resets the timing of that 12G signal before handing it back to the SDI copper cable.
It's like a runner stumbling across the finish line and someone catching them, standing them upright, and perfectly syncing their stride before sending them on the next leg of the relay.
That is exactly what it's doing. You maintain zero latency, perfectly pristine video.
So the next time you're sitting on your couch watching a flawless zero-lag live sports event, you'll know it's not magic making it happen.
No magic at all.
It's these incredibly compact, low-profile fiber optic receivers doing the heavy lifting in the background.
They are engineered to be practically invisible but highly resilient.
But it leaves you with something to really chew on.
Oh, definitely.
If a rugged little box the size of a smartphone can perfectly reclock and push massive 12G video signals 10 kilometers on just 2 watts of power today, what does that mean for the future of completely decentralized, uncompressed, global live broadcasting?
It changes everything.
Right. If we can perfectly pipe uncompressed 4K signals anywhere, will we even need traditional production trucks on site in a few years? It really makes you wonder if the giant equipment we started talking about is already becoming a thing of the past.